Digestive System, and you're going to have to know it on the cadaver actually, which will open the cadaver in about 15 minutes. But let's start at the top. So, oral cavity, obviously, and then I'm expecting you to know the different parts. You can't see the different sections of the pharynx on this, but I'm expecting you to know that. These are salivary glands. I'll show you this one in a second. So that is the sublingual, obviously, it's beneath the tongue, and that is the submandibular, and the parotid is here, it's on this side. There's your parotid there. What do salivary glands do?
Start chemical digestion.
They begin chemical digestion of what?
Carbohydrates.
Carbohydrates, that's the main one, but also what else? Lipids. Yeah. And you know that because there are salivary amylases and salivary lipases. Okay, so therefore that chemical digestion begins. What else does saliva do?
Keeps your mouth from drying out.
Yeah, keeps your mouth from drying out, that's very true. When you are thirsty, that means you need to drink water. I think your text has about a whole chapter on that. Anyway. What else does it do?
Mash the food together.
Yeah, you start to dissolve the food. For digestion to correctly work, food must be dissolved. Okay? And dissolution occurs there. So you swallow the food, and what happens is the epiglottis gets pushed back. This is the epiglottis. You swallow the food, it gets made into a ball, and then that epiglottis will prevent food from going down the respiratory tract. Okay? And then it gets into the esophagus. There's the esophagus there. Okay? And it gets pushed down by a what force? Excellent. So peristaltic forces will push it downward. And this also turns it into a ball of food, which is called what? A bolus. And that food will pass through the lower esophageal sphincter, which is there, and will go into the stomach. What happens in the stomach?
Food is pretty much dissolved.
It becomes acidic, and then the food gets mostly dissolved. And at this point, what is the food called? It's called climate. Excellent. So the stomach is acidic. What is the pH of the stomach when digesting?
Like 3.
It's less than 3 when digesting, and it's 4 when it's not digesting. Okay. So yes, between 3 and 4. And then the two sphincters, the lower esophageal sphincter, which I'm telling you about, what is the other sphincter called?
Something hiatus?
No.
What
No.
pyloric?
It's a pyloric. It is a pyloric.
What is it?
It's a pyloric sphincter.
Pyloric.
They both close. Why? Why do they close?
To keep food from like coming up into the esophagus.
Yeah. So the role of the lower esophageal sphincter is to prevent stomach acid from getting into the esophagus. The stomach is protected by a big thick layer of mucus, but the esophagus does have mucus, but not enough to protect it against stomach acids. So you'll start ultimately digesting your esophagus.
What was the first sphincter called?
The lower esophageal sphincter,
Okay.
the LES. So that's the role of those. Okay. And so the parts of the stomach. What is this part up here for? No, not that. That's the fundus there. So this is something else on the side. It's the cardiac region. Yeah. This is the body. What is this region down here called?
The tail? Is it the tail?
Not the tail? Is
I don't
what
know.
Are you thinking of pancreas?
I'm thinking pancreas, sorry.
Okay.
Ah.
Yeah. Okay. I've never heard of pancreas called the tail.
Yeah.
This region here. Is it in connect? Good. The pyloric.
You said it was the pyloric.
I know.
Yeah, so this is the
Pyloric.
pyloric sphincter. This is the
Okay.
pyloric region.
Pyloric region, okay.
These are called what? What are these folds called? Rugae. Gastric rugae. Why do we have gastric rugae?
When the stomach's full, it expands.
It allows expansion. Excellent. And it's for another reason as well.
So for churning?
Helps churning, yeah. Stomach is muscular, and these actually do help with the churning. And the last one is it expands the surface area. Digestion happens on the cells itself, or it completes on the cells. So you want to expose as much food to the cells, and if you expand the surface area, you can do that. So from here on in, the surface area of the lumen is expanded as best it can. So it does that. Then the stomach contents get passed to the duodenum, which is this. Okay, and in the duodenum, a few things happen. Firstly, stomach acids get neutralized. Okay, and it's the reverse equation to what we learned about the other day. So that bicarbonate basically neutralizes stomach acids. And then also the pancreas, the gallbladder, and then the liver contents get put into the lumen here. It's secreted here. Then we go from the duodenum to the jejunum, which is this here. And in the jejunum, we have absorption. That's where absorption really begins. What is absorption?
Where nutrients are put into the bloodstream.
Fantastic. That's exactly what it is. So nutrients are here, they're digested, so they're digested down into their constituents, and they get transported into the bloodstream here. Okay? And this is the bloodstream. Obviously, what is that? That's a lacteal. So what gets absorbed into lacteals?
Lipids.
And then what gets absorbed here?
Nutrients.
Carbohydrates and proteins. And then with the vitamins, I think that's what you said. I can't hear you.
That's a protein and glucose.
Good. Yep. Okay. Protein and glucose. Vitamins, if they are lipid soluble, they'll be absorbed here in the lacteal. If they are water soluble, they'll be absorbed here. Okay. And we're not actually talking about vitamins. And then where does the absorbed nutrients go from here? To the liver.
Gotcha.
And does anybody know what system it's transported? What system does it go on? So it's not systemic circulation, it's not which one is it?
Autonomic?
I don't know.
Is it
I think it's
autonomic?
hepatic.
Autonomic?
Hepatic.
Oh, hepatic. Okay.
Yeah, hepatic. Goes to there. That's the hepatic portal vein. So nutrients get absorbed here, and then they get transported to the liver via this hepatic portal circulation. Okay. So that is the hepatic portal vein. This here is the hepatic triad. It includes a bile duct and the hepatic artery and the hepatic portal vein. Okay. So food gets absorbed here, gets transported to the liver. This is the liver. That's the hepatic triad there, and there it is there. You'll see it's on the between the hepatic lobules. Okay, so there it is there. So that's the portal vein there, hepatic portal vein. So that is rich in nutrients, and these nutrients get deposited here into these sinusoidal capillaries. And inside these sinuses are hepatic macrophages, which you see there. And basically, at this point, they're all nutrients. So the nutrients then get absorbed into hepatocytes. So these are hepatocytes. And these hepatocytes will secrete nutrients into the blood here if necessary. Okay, so these hepatocytes control blood chemistry, especially for nutrients. And then those nutrients, then the nutrient-rich blood here is going to go to the central vein, and then that central vein is going to go to the vena cava. Okay. Also, the hepatocytes produce bile. Okay, bile assists in chemical digestion. It's basically a detergent, so it breaks apart fat molecules. Okay. So the bile gets secreted into there and then goes to that. And then that bile duct, these are hepatic bile ducts. So that bile will then get sent to the gallbladder where it's stored. And then the gallbladder, that's the cystic duct. So that's the duct that goes to the gallbladder. That is the hepatic ducts. They're the ducts that go to the liver. And then this one I'm calling the common bile duct. This common bile duct is there. That's the common bile duct, and then that drains into the duodenum here. Okay, so bile goes to here. So bile gets put into the gastrointestinal system in the duodenum and then is excreted. Why? Why do we excrete bile?
Because the body can't process it anymore, so it has to get rid of it.
It's toxic, so the body doesn't want to, the body can't process it any further. Why are we removing bile? Where does bile come from?
Undigested food.
No. No. On the liver, yeah, but why is it in the liver? So bile is the heme group of hemoglobin. We're constantly recycling red blood cells. The bile is how we excrete the toxic part of hemoglobin. Okay. What it also does is help dissolve lipids, which is what I already told you. It basically is like a detergent, so it breaks apart lipids. Anyway, so that's, yeah.
Bile is what emulsifies all the fat.
It emulsifies, yeah, exactly. And emulsification effectively is taking large, what are called micelles, large globs of fat, and then making them much smaller. If you make it smaller, it's easier to absorb the edges, basically. Okay. So we got through the small intestines, and now that is the ileum there, and this is the cecum, and that's called the ileocecal valve. So this is where food contents go from the small intestines into the large intestines. This little pouch down here is the cecum, and then that little extrusion there is the appendix. Okay? The cecum, what it does, and the appendix is change the intestinal flora. So the flora that's in the small intestines, which is the bacteria that's in the small intestines, largely bacteria, gets changed, and that effectively is an E. coli farm, the appendix. So E. coli is found naturally in your large intestines, and it produces vitamin E. Does anyone know what vitamin E is for?
Skin.
Yeah, it dissolves scarring. So if your skin, it makes your skin more supple because it basically digests collagen. Yeah. So that gets in here, but it also helps to digest foods. So that's the ascending colon. The transverse colon is that. This is the descending colon, and this is called the sigmoidal colon. And then the sigmoidal colon, that's the end of the sigmoidal colon. There's the rectum, and then there's the anal canal, and there's the anus. And then that's feces right there. Yeah. So what the large intestines do is they complete lipid digestion. Okay. Also, some lipids are absorbed in the colon as well. Then they also reabsorb electrolytes and fluids. Okay.
That's where most of our water goes.
Yeah. This is where it gets retained. So you put water into the stomach and actually everywhere, you get water into it to dissolve the food, therefore you can digest it. But then you want to retain the water and retain it in the large intestines and electrolytes. And then that's feces production. That's it.
So the electrolytes like sodium, potassium, all that, they don't get absorbed, like they don't burn anything, they keep on.
So actually the electrolytes get moved around as necessary. They just, when you want to move water around, you can't actually, there is no water pump. What they do is pump sodium, and sometimes potassium, but usually it's sodium, and then water will follow it by osmosis. So electrolytes get used to move water around. The electrolyte levels in the blood are actually controlled by the kidneys, obviously. We'll talk about that next. Any questions?